Getting into dietary fat, we're going to talk about the structure of fats, triglycerides and fatty acids, cholesterol, plant sterols and phospholipids, digestion and absorption of fats, metabolism of fat, role of triglycerides in our diet, hydrogenated fats, and are there good or bad fats? Structure of fats, lipids are the components of fat that are characterized by insolubility in water. So kind of like our dietary fibers, fats have a tough time being water soluble. They're not very water soluble. Lipids exist in three main forms in food. Triglycerides, that's 5% of the lipids that we're going to talk about are triglycerides. You also have sterols and plant stanols and phospholipids. We have the fatty acid. A fatty acid consists of a straight chain of an even number of carbon atoms with hydrogen atoms along the length of the chain. And at the end of the chain, a carboxyl group. This here is your carboxyl group at the other end. It is that carboxyl group that makes a fatty acid an acid, so carboxylic acid. Fat types, we have maybe heard of saturated fatty acid. This means that all carbons are saturated with single bonds. So here would be all carbons, and they're all filled in with single bonds of hydrogen. They tend to be very stable and mostly solid at room temperature. Some good examples would be cocoa, butter, coconut oil, or palm oil. You have your monounsaturated fatty acids. They have one double bond. Okay, so we can see here one double bond. And we also see that they're missing one hydrogen atom. Okay, so monounsaturated. So one is missing. Olive oil tends to be the most common. Other food sources are canola oil, avocado, peanut oil, and most nuts except walnuts tend to be majority monounsaturated fat. You have your polyunsaturated fatty acids. That's more than one double bond. It's our least stable. We find that in germs of grains, food sources, safflower, sunflower, and sesame and soybean oils. So again, here we see multiple double bonds and multiple carbons not attached to hydrogen. Cholesterol or sterols, you have endogenous cholesterol that's made by the liver. So the liver can make about 1,000 milligrams a day, making cholesterol a non-essential nutrient. So it's a non-essential nutrient. Doesn't necessarily mean we need to fear it, but since our body can produce it on its own, we don't need to get it necessarily from the diet. Exogenous cholesterol, that's what we get from the diet, and that's approximately 300 to 400 milligrams a day. That's typically only found in foods of animal origin. So that's where we get our dietary cholesterol from primarily. Plant sterols and stanols. Sources would be wood pulp, leaves, nuts, and vegetable oils. The actions of plant sterols and stanols would be to interfere with cholesterol absorption by competing with cholesterol for uptake into the myocells. So because of that reason, because it competes with cholesterol absorption, it tends to have cholesterol lowering properties. A daily intake of 2 to 3 grams of plant sterols has shown to reduce low density lipoprotein or LDL bad cholesterol by 10 to 15%. That's some data published by the American or the Heart Foundation. Fat digestion and absorption. We have lipid digestion. That's fats are hydrophobic. We already mentioned fats do not mix well with water. Digestive enzymes will help make them more hydrophilic, so mixable with water. Goal of fat digestion is to dismantle triglycerides into monoglycerides, fatty acids, and glycerol. So that will happen in the small intestine. Gallbladder will release bile. Bile acts as an emulsifier. Pancreatic lipase would be an enzyme that's also released to help further break it down. And then we have hydrolysis, where triglycerides and phospholipids. So all of that was key in the breakdown of our fats. It's important to realize and understand the body can make fat from protein and carbohydrate. So when we look at our fat will go right into acetyl enzyme CoA and then can be used as an energy source. But carbohydrates can be used to manufacture dietary fat, as can proteins. How does fat get transferred in the body? This is important to realize because a lot of people will talk about insulin and kind of fearmonger with insulin. Insulin is a storage hormone. It helps store glucose into the cells. It also will help store amino acids into the cells. Dietary fat or triglyceride is unique in that it does not require insulin for storage. However, it can absolutely be stored. So chylomicrons are what package and unpackage fatty acids to be stored. So it's the largest and least dense. And yes, fat can still be restored regardless of if there's an insulin response at all, as insulin or chylomicrons would act as the carrier or as insulin would to store fat. And that chylomicrons is mainly responsible for transporting diet-derived fats. It also removes remnants from the blood. So the liver will remove any excess fat from the blood. You have very low density lipoproteins made in the liver. Low density lipoproteins, cell needs liver regulation. And then high density lipoproteins. They remove cholesterol from cells, carry cholesterol to liver for recycling, and they have anti-inflammatory properties. Role of triglyceride in our diet? Well, it's a very concentrated energy source at 9 kilograms per gram or 37 kilojoules per gram. Virtually unlimited ability to store fat. So the body tends to see fat as a very high currency, as we have a virtually unlimited ability to store it as adipose tissue for later use. So all of our adipose tissue is simply just stored energy or stored calorie to be used in case of famine. Fat also secretes hormones, the more popular one being leptin. Fat serves as a skin insulation, shock absorption, cell membranes, and cell signaling pathways. Lipid metabolism, adipose cells store fat after meals. Lipoprotein lipase hydrolyzes triglycerides. Triglycerides reassemble inside adipose cells. The chylomicron will transport them and then allow them to be reassembled in adipose cells. Using fat for energy, so protein sparing, so fat can actually have a protein sparing effect. And energy deprivation, like we mentioned, fasting. Our bodies can produce ketone bodies from stored body fat and allow us to hunt or sustain life in the absence of calories. So if you think of body fat as just stored calories, it helps us deal a little bit well with various times in our lives where we might be required to fast, or if we have long days where we're not required to eat. Our body is fully capable of running off that stored energy. Hydrogenation of fat. So what is hydrogenation? It's a chemical process used to harden fats to prevent unsaturated fats from rancidity. So it's basically a way that manufacturers of food are using to increase the shelf life of saturated fats. Commonly, oleic acid and linoleic acid are both converted to stearic acid when fully saturated or hydrogenated. So these two fatty acids are not saturated fats, but they become saturated fat through the process of hydrogenation. So hydrogenation is also the process of converting unsaturated fats and oil to saturated fats and oils. Problem with hydrogenation is there's no control over which double bonds are broken. So we're literally changing the molecular structure of the fat. Formation of trans fatty acids. Trans fatty acids have actually been banned in many areas, and increasing your risk of cardiovascular disease. So good or bad fats? There aren't necessarily, I wouldn't put a good or bad, but there are some benefits of long-chain fatty acids, or EPA-DHA, that's omega-3 fatty acids. So we have two fatty acids that are essential: linoleic acid, so we're going to find that in vegetable oils, red meats, nuts, seeds, it's an omega-6 fatty acid, and alpha-linolenic acids. Foods that we find that in are canola, flaxseed, soybean, walnuts, green vegetables, and omega-3 fatty acids. Our long-chain fatty acids are those with 14 or more carbons in their chain. They're found in most fats and oils, and including olive oil, soybean oil, fish, nuts, avocado, and meat. The long-chain fatty acids tend to have anti-inflammatory properties, which make them preferred as far as dealing with inflammation in the body. So if a client or yourself has a high amount of inflammation, paying attention to the EPA, DHA, and the long-chain fatty acid would be a definite good idea to follow or good practice to follow. All right, lipid recommended intakes. So dietary fat should provide at least 15% of total energy, 20% for women of reproductive age. There's definitely a lot of leeway. Our body can, there are certain populations that do well on very, very high fat intake, and there are other proponents. So for example, a famous researcher and author, Dean Ornish, he advocated very, very low fat diet. So a lot of that's going to be in the palate of your client and the individual preference. Upper limit of fat intake, ideally the government RDA would want it to be less than 30% of total energy. However, again, there are plenty of populations, very healthy, that greatly exceed that. But again, these are the government standards. Saturated fat, the RDA would be less than 10% of total calories coming from saturated fat. Our recommendation would be to look at the type of fat first, so fight inflammation first, then look at sustainability or palate, metabolic syndrome, or people who are not as insulin sensitive or maybe a little bit overweight, maybe they're overproducing a lot of insulin, they may benefit from a higher fat diet. That's definitely something run by their doctor, so they're not producing as much insulin. And lifestyle and relationship with food. Some people just prefer higher fatty foods. We can definitely work that into their plan. So we tend to find that most people benefit from going a little bit above the RDA suggestion for fat. And as we talked about in our carbohydrate section, carbohydrates definitely are not the issue. It's just a lot of the carbohydrates that we're consuming are monosaccharides, which tend to be the least nutrient dense and provide the highest amount of inflammation. So sometimes by increasing our clients' fat intake with anti-inflammatory fats, we can help them feel better, reduce some inflammation.